Hello everyone. Uh, my name is Arobagai. Today I'm going to show you the one of the tests that is done on the well side. The measurement of fluid level, dynamic fluid level, or DFL, SFL. Okay. The test itself is sonic log test. It's a test that is done on the well side, oil well side. Okay. The content is the introductions, equipments, ecometer, an ecometer compact gas can in nitrogen gas springs cylinder, procedures, and conclusions. Okay, let us jump into it. Okay, so we start with the introduction. Introduction itself. What is it, the instrument that we use or the operation itself? We call acoustic fluid level survey determines the depth fluid levels by generating the acoustic pressure force that is travel down the wells and then reflect off the fluids and then returns back to the surface where it is recorded by sensitive internal microphones inside the fluid level gun to the ecometer. Ecometer is a bring it out in a form of strips. Okay, so as you see in the figure here, the strips is here in the acoustics signal. You see the signal. This is inside the ecometer. They came out in a form of strips. Okay, then here in the wellhead we have as you see we have a Christmas tree, a gate valve. So in a gate valve we have a pressure gauge. We remove a pressure gauge and then we install the gas gun. Okay, so we connect it. After we connected it, we connected also to the equipments called ecometer. After the ecometer, okay, we shoot the nitrogen gas through the annulus until it reflects on the fluid surface as you see in the liquid level. So in the liquid level here, it bump backs, okay, and then it go back again into the instrument, into the guns, and then it recorded in a ecometer. Okay, so as you see here is a simple illustrations. We have acoustic gas guns and a sensor. So here is acoustic pulse that you send through annulus and then bump back through the fluid levels. After that, you see here the greens is a reflecting pulse. Okay, so it go back and it record it in a commit. Okay, that is it. So let us see the equipments we use. We have the cylinder. This is cylinder, and then we have ecometer with strips, recorder strips, and we have the gun itself, and then we have the strips, and then we have the cylinder we recorded in and then we have the connector. So let us see them one by one. Ecometer model M. We have several models. Okay. So it itself is a portable device that is channel strips chart recorded that use acoustics to obtain the distinct levels in a casing annulus of the well. So this is the device by itself. Okay, we use it. So let us go. And number two is ecometer compact gas gun. It is a gun itself. So it 10 cubic inch volume chamber and a quick open gas valve is used. Quick open. You can use these gas guns uh, um, and you can connect it here. This is where you connect it to wellhead, and here you can connect it through the black wire to the ecometer. Okay, and this is a the gun itself. So number three is a nitrogen gas strips cylinder, the cylinder itself. So a cylinder is a portable cylinder that is containing 20.8 cubic feet of nitrogen gas, which is ignited gas. Do not react with a fluid inside down at a surface pressure rate of the 2000 above psi or more. So itself, why we do use the nitrogen gas, because it is ignited, it doesn't react with the fluid inside the well. Let's see why we use it. So the procedures is very simple. You first ensure that the casing's valve is closed. Then after that you remove the gas pressure, okay, and then gun you put it into the casing valve. After that, charge it with charge a volume with a compressed nitrogen gas to 200 ps or p ps psi or over casing pressure. Connect the cable between a gas gun and ecometer strips chart recorder. Casing valve in between a gun and well is open, and then the casing valve is connected to well to flow lines is closed. This isolates the well so it is only in communication with a fluid level. So you isolated the whole flow lines, and then the only remains is a well, and then you connect your guns to the well. That is it. And then we come to the conclusions. How do you determine the distance of the fluids to the surface, after the surface? Simple. The number of the joints of the tubing, you multiply them by the pulse records. So it's very simple. The length of tubing times the number of the poles. How you see here, the number of the poles you count from the strips here. 1, 2, 3, 4. After that, you know the number, and then multiply by the number of joints. That's the length of the surface you got. Thank you. If you like my video, give the thumbs and subscribe. And wait for the next video. Thank you.